Hello everyone. Today, on November 14, 2025, we face a weather forecast that's more than a prediction. It's an urgent message from our planet. The atmosphere is sending us a clear warning, and the scale of what's unfolding is unlike anything we've seen in recent memory. This is not just another stormy day. This is a pivotal moment that will be studied for years to come. Across Europe to Western Russia, meteorologists track a colossal weather event. Their screens are lit up with swirling cloud masses, and the data pouring in is staggering. The sheer size and intensity of this system have experts on high alert, as it threatens to disrupt life for millions. This isn't just a storm, it's a massive, persistent pattern set to dominate for 10 days. Unlike typical storms that pass in a day or two, this one is digging in, refusing to move on, and bringing relentless waves of severe weather. It's a multi-hazard event, throwing dangerous weather at different regions simultaneously. Floods, thunderstorms, and ice storms are all happening at once, stretching emergency services and communities to their limits. This large-scale system is what climate scientists have warned about, now unfolding before us. For years, experts have cautioned that a warming world would bring more extreme, persistent, and unpredictable weather patterns. Today, those warnings are reality. Normally, weather systems move along, but this pattern is stuck, creating a storm conveyor belt into Europe. The jet stream, which usually guides storms away, has stalled, trapping this system in place and funneling moisture and energy into the continent day after day. The impacts will stretch from Ireland to the Ural Mountains, a continental-scale challenge. No region is untouched, and the scale of coordination needed to respond is unprecedented. Amplified by climate change, this event is supercharged by record-breaking ocean heat. The Atlantic and surrounding seas are warmer than ever, providing extra energy and moisture to fuel the storm's intensity and longevity. This warmth is the extra fuel, a direct manifestation of climate change principles. It's not just a background factor, it's the engine driving this storm's power, making it more dangerous and harder to predict. We'll break down this mega event into 3 hazard zones, each facing its own unique set of threats and challenges. Understanding these zones is key to preparing and responding effectively. Catastrophic flooding in the west, where rivers are overflowing and entire towns are at risk of being submerged. Emergency crews are working around the clock to evacuate residents and protect critical infrastructure. Violent thunderstorms in the south, bringing torrential rain, frequent lightning, and the threat of flash floods and landslides. Communities here are bracing for power outages and dangerous travel conditions, and a crippling ice storm in the east, coating roads, trees, and power lines in thick ice. This region faces hazardous travel, widespread power outages, and severe disruptions to daily life. Understanding these threats and their links is crucial to grasping the situation. Only by seeing the full picture can we hope to respond, adapt, and protect our communities in the face of this historic storm. How does a weather system get this big and stubborn? What makes it so persistent, stretching across continents and refusing to budge for days or even weeks? The answer lies in a remarkable phenomenon known as the Dipole Pattern, which often sets up over the North Atlantic Ocean. In this setup, a powerful high-pressure system sits side by side with a deep, persistent low-pressure system. These two forces become locked in a kind of atmospheric tug-of-war, holding their positions for extended periods. The dipole acts like a master conductor, orchestrating the movement of air masses and steering weather systems across thousands of kilometers, from the heart of the Atlantic all the way to Europe. This configuration creates a kind of atmospheric superhighway, with the jet stream acting as a fast-moving conveyor belt, channeling storms directly toward the European continent. Any disturbance that forms over the Atlantic is quickly swept up and funneled eastward, resulting in a relentless train of storms that seem to arrive one after another, barely giving the land a chance to recover. Under normal circumstances, high and low pressure systems drift, weaken, and eventually break apart. But when a dipole is part of a blocking pattern, it stalls the usual west-to-east progression, causing weather to linger and intensify. The result? Regions caught beneath the storm track endure days of relentless downpours, saturating the soil, swelling rivers, and increasing the risk of flooding and landslides. Understanding how this dipole pattern works is crucial. It channels not just storms, but also warm, moisture-laden air over land, fueling even more intense rainfall and amplifying the impacts. This isn't just a random occurrence, it's the result of powerful, large-scale atmospheric physics at work. turning the North Atlantic into a relentless storm factory, with consequences felt far downstream. Let's talk about the fuel that powers these massive storms. A storm needs energy, and it's coming from ocean heat. The warmer the ocean, the more energy is available. The North Atlantic and Mediterranean show record-breaking temperatures, critically warm. These regions are heating up faster than ever before. This heat transfers to the atmosphere through evaporation, creating a juicier air mass loaded with water vapor. The more heat, the more evaporation, and the more moisture in the air. More water, vapor, means more rain. For every degree Celsius of warming, air holds 7% more moisture. This increased moisture content can lead to heavier and more intense rainfall. This super moist air produces torrential rainfall, overwhelming drainage systems, and turning rivers into torrents. Cities and towns are often unprepared for such deluges. Extra water vapor releases energy when it condenses, acting like a storm turbocharger. This process releases latent heat, which further fuels the storm. This latent heat warms the air, causing it to rise faster, pulling in more moist air, creating a feedback loop. The storm grows stronger and more intense. This intensifies storms, turning low-pressure systems into bomb cyclones. These cyclones can cause widespread damage and disruption. The record ocean warmth is the central plot point, amplifying every aspect of this weather system. It's a key driver behind the increasing frequency and intensity of storms. It makes the air wetter, leading to extreme rainfall and flooding. Communities are facing unprecedented challenges as they deal with these extreme weather events. It makes storms more powerful by injecting latent heat energy. This added energy can turn a regular storm into a severe weather event. We're witnessing a direct connection between warming oceans and intensifying weather. The evidence is clear and undeniable. The heat absorbed by seas over decades is now released as meteorological fury. This is a stark reminder of the power of nature and the impact of climate change. The first bullseye for this megasystem is Western and Central Europe. Countries like Ireland, the UK, France, and Germany face a severe hydrological event, a historic flood. This region is in the path of an atmospheric river, a corridor of concentrated water vapor from the Atlantic. When this river makes landfall, it causes catastrophic rainfall. The ground is already saturated, leading to severe surface water flooding as drains are overwhelmed. Runoff pours into rivers, causing extreme river flooding. A bomb cyclone could hit, intensifying winds and rainfall, creating a nightmare scenario. The combination of an atmospheric river, saturated ground, and potential bomb cyclone creates extreme peril. Emergency services will be stretched to their limits, battling a relentless siege from a sky that won't stop raining. While the West braces for floods, Southern Europe and the Caucasus face atmospheric violence. The warm Mediterranean fuels severe convective thunderstorms, forming supercells with destructive hail. These storms have powerful updrafts, creating large hailstones capable of shattering windows and damaging infrastructure. There's also a chance of a metacane, a rare Mediterranean hurricane, bringing hurricane-force winds and storm surges. This severe event poses a unique threat, with giant hail, damaging winds, flash flooding, and potential metacanes. Forecasting exact impacts is difficult, straining emergency responders across a wide region. As the storm moves east, it encounters a massive dome of frigid Arctic air. Eastern Europe and Western Russia face a transition to winter, with a snow and ice storm. It begins with heavy freezing rain, creating black ice and coating surfaces in ice. This is followed by heavy, wet snow, putting immense stress on structures. The combination of ice and snow risks roof collapses and power line failures. The greatest threat is a multi-day electrical grid failure, leaving millions without power in freezing conditions. Authorities must prepare for a crippling infrastructure failure, leaving populations vulnerable. To grasp this event, we must understand the science amplified by climate change. Warmer air holds more moisture and energy, turbocharging storms. The Arctic is warming faster, affecting the polar jet stream, making it wavier and less stable. This allows Arctic air to plunge south and warm air to surge north. Warmer oceans load the atmosphere with moisture and energy, making storms wetter and more powerful. A destabilized jet stream creates persistent weather patterns, steering supercharged storms. These mechanisms amplify each other, producing an intense, widespread, and persistent weather event. This is a perfect storm created by climate change, affecting millions now. It underscores the urgent need to adapt infrastructure and response strategies to a changing climate. The threat of large hail in southern Europe is a fascinating aspect of the forecast. Warmer seas lead to a more unstable atmosphere, fueling stronger updrafts in thunderstorms. These updrafts create hail, lifting water droplets high into the atmosphere to freeze and grow. In super-energetic storms, updrafts are strong enough to support large hailstones. These hailstones grow layer by layer until they become enormous, surviving the fall through warmer air. A warmer world may lead to less frequent small hail, but increases the risk of giant destructive hail. Climate change isn't just turning up the thermostat, it's creating more extreme weather events. This event is a cascade of risk, with 3 large-scale emergencies happening simultaneously. In the west, a massive flooding disaster. In the south, damage from hail and thunderstorms. In the east, a crippling ice storm. Europe's response agencies will be stretched thin, unable to move resources easily between disasters. This highlights a vulnerability in emergency management systems designed for discrete disasters, not continent-spanning crises. Communities will face profound impacts: evacuations, crop destruction, and power failures. Infrastructure is at risk, with floods washing out roads, hail damaging solar farms, and ice storms bringing down the grid. This mega-weather event is a reality check, demonstrating climate-amplified events scientists warned about. It's not a distant problem. It's here, affecting millions now. It underscores the urgent need to reduce emissions and adapt infrastructure and response strategies. This is what climate change looks like.